Dear students, today's class is about the rigidity modulus. It is another property of the material. Already we have discussed the Young's modulus, rigidity modulus, bulk modulus, and the Young's modulus is also the property which relates the stress and the strain, longitudinal stress and longitudinal strain. It is another property called rigidity modulus. You know well that rigidity modulus is defined as a tangential stress to shearing strain. The rigidity modulus is equal to, it is indicated by the symbol N, the tangential stress divided by shearing strain. The stress is nothing but force by area, and the strain is the angle phi. This is a metal disc. It is the experimental wire. The rigidity modulus of this wire has to be determined. This wire is considered as a cylinder like this. A part of the wire, a part of the experimental wire is considered as a cylinder here. Here we are going to drive the expression for work done in twisting the experimental wire. It has the property of rigidity modulus. It has some rigidity modulus property. Our job is to drive the expression for the work done in twisting the wire. See here, the one end of the wire is tied rigidly and the other end is connected with a circular disc made up of some metal. So the force is given here. The twist is given here. When we give a twist, this experimental wire having rigidity modulus N twisted. This part of this wire, the part of this cylindrical wire of length L and the radius A, the radius of the wire is small a and the whole length is capital L. It is made up of large number of concentric cylinders. The concentric cylinder means, so this wire, the part of the wire is taken as cylinder. So the concentric cylinders, it is made up of concentric cylinders like this. Here it is one cylinder, this another cylinder. Likewise, it is made up of large number of concentric cylinders. So the center of the cylinder, the center is the same, so it is called as concentric cylinders. The upper part here it is a fixed and the lower is twisted through the angle theta. The cylinder is displaced when it is twisted. It displays to the position. See here it is A, it is B. So the AB is shifted to AB dash. See here, AB is shifted to AB dash here. So through the angle, this angle, the deviation angle is phi here. It is phi. So now the cylinder is displaced to a position AB dash from AB. From this diagram, B dash, this area is equal to x into theta. It is the value theta. It is the value x into theta. So the x into theta, this triangle is equal to this triangle. See here, this one. So this x theta is equal to, the value of it is this L into phi. This area, the length and this angle phi is equal to L phi. X theta is equal to L phi. From this phi is equal to x theta by L, we know that the rigidity modulus is equal to tangential stress by tangential strain. So the strain is nothing but here phi. So we are cross multiplying. So the tangential stress or the force is equal to rigidity modulus into phi. We know the value of phi. Substitute here. Substitute on simplifying. We get the tangential stress is equal to nx theta by capital L. Already we know that the tangential stress is equal to tangential force by area. Force by area. So the tangential force is equal to cross multiplication. Tangential stress into area. The area over which the tangential force acts is 2 pi x into dx. So the force, substitute the value here, force is equal to the tangential stress n x theta by L into area 2 pi x into dx. So next we are going to determine the moment. Moment is nothing but force into distance. It is the value of force. So distance, the distance displaced on applying the stress is equal to x. So force into distance, x is called the moment. We know the value of force. On substituting these values, we get 2 pi n theta by L into x cube into dx. So the twisting moment or twisting torque on the whole cylinder of radius A is given by, we are going to integrate this value. The constant values are taken out and the integration lower limit is 0. The maximum is up to the radius A. So it is variable quantity x cube. This x, on integrating the x cube, we will have a power 4 by 4. On substituting this value and simplifying, the twisting moment is equal to pi n a power 4 by 2L theta. So it is the expression for work done or twisting moment or twisting torque in twisting the wire.